Okay, this is our second session, and I'm going to talk about the basic building blocks of Java. So the objective of this lecture is see what are the components of Java program. I will explain them. We have statements, blocks, and etc. What is a Java source code file and how we can name a Java source code file. What is statements and what are the components of one statement? What is variable? How we can declare the variables and initialize the variables? What is operators? What types of operator we have and how we can use them and some rules in the operators. So the Okay, so let's see what are the components of Java programs. The first component is statement. So each line of code that ends with semicolon in Java program is called a statement. For example, int x equals 20 semicolon. That's one statement. The group of statements that are inside opening braces and closing braces is a block. And then we have classes. So in order to create objects in classes, in Java, we define classes, right? So classes contains methods and variables. And in each Java programming language, we have at least one class. And programmer can define new classes, so define new objects, right? And also, you should know that we have, as I told you in the previous session, SDK, and inside SDK we have so many predefined classes and packages that we can use. Instead of writing them manually, we can use those predefined classes. The other component of Java is methods. So methods are exactly the same as functions. So functions in C or C++ are a group of lines of code, right, that accept some input, manipulate that input, and return a result as the output. That's exactly what we have in Java and is called method, right? Methods are inside and will be defined inside the classes, right? That's the other point that you need to keep in mind. And finally, we have the main method. Each Java program needs to have a main method. Inside the main method, you will create sample of classes. You will call the methods, right? Methods of those classes. And the main part of your program will be inside your main method. So how you can create a main method, it would be by public static void main string args, and then inside the braces you will have the statements. Here in this slide I'm trying to show you one example to see each component of this programming language. As I told you, we have class, right, as one component. As you see here, class grades is one example of a class. Then inside this class, we have a main method, public static void main. Right, so that's the main method of this class. Then I mentioned that each statement is a line of code that ends with semicolon. So here, each line of these codes that are inside the main method are one statement. For example, int grade or system.out.print enter test grade, right? Each of these are called one statement. Then we have blocks. Blocks are a group of statements that are inside opening braces and closing braces, right? So as you see here, I've showed you an example of the block. Okay, so as you see, the other thing that you need to know is that the whole code that you have, the whole Java code needs to be inside a file, right? And the name of that file needs to follow some rules. The first one is that whatever the name of that file is, it needs to be followed by a file extension, right? .java. Then in each program, Java program, we will have, right, one or more classes. So the name of the file needs to be matched or needs to be the same as the name of the class that is declared to be public. For example, in this example, you see we have class box public static void main system.out.println what's up docs, and then public class Daffy public static void main string args system.out.println your blah blah. And then as you see here, we have two classes, right? The main class, and then here we have the public class. So the name of the file needs to match the name of this public class daffy.java, right? That's one rule. So what if we don't have any public class and we just have one class, for example, like what we have in this example, class yada public static void main string args system.out.println. So as you see here, the name of the file needs to be the same name as this class yada, right? Yada.java. So we have in Java statements. Statements in Java are made up of reserved words, identifiers, literals, operators. Reserved words are words that have predefined meanings in the Java language, like int, double, main, right? They are reserved words. Identifiers are words that are created by programmers for names of variables or functions or classes. So you, as a programmer, will create and use some names for your variables or classes. Then we have literal. Literal values written in code like strings or numbers. We have integer literal, float literal, character literal, string literal. So integer literal like 4 or 18 or -10. Float literal like 4.5 -12.9 5.0. Character literal like F, A. String literal like hello, bye. So they are in double quotation, right? Then we have operators. Operators are special symbols that perform certain actions on their operands. They can be unary, binary, or ternary. A unary operator has one operand, like plus plus x. A binary operator has two operands, like x plus y. A ternary operator has three operands. So we have then escape sequences. As you see here, we can use these escape sequences in our programming language. For example, \n, when you use that, it will, the next output will go to the new line, right? Or if you use \b, then what it will create a backspace, right, in the output. Or single quotation, it will create and will output a single quotation. So these are some escape sequences, right? And their meanings that you can use when you are going to print something in your in the output on this screen, right? When you write down system.out.println. So, so in Java, like other programming languages, we have comments. Comments are those when you are going to add some information about a line of code or explain something about your line of code, you will write down the comment. Comments in Java are two style, block style and line style. So the block style comments are would be inside a slash star and again slash star slash as you see in this example. For the line style, that comment will be after double slash as you see here. We have int x double slash, this is a comment, or x equals 3 double slash, this is a comment. So let's see some important thing about variables. So variables in Java has each variable can have a name, type, size, and value. The name is the name of the variable, right? The type specifies the type of that variable, whether it can be integer, it can be double, it can be a character or anything. Size will specify the size that variable will have inside the memory. So the size is based on the type. So integer, double, and character are the types of variables, and each of them can have a separate size in the memory. And then we have a value, so each variable can have a value. For example, int x equals 20, right? So int is the type of that variable, x is the name of that variable, and the value here that has been assigned to the variable is 0. Then we have identifiers. Identifiers, right, as we talked before, are those names that would be created by programmers for variables or for functions or for methods, right? And they can have some rules when you as a programmer create an identifier. So first is that in Java, right, the identifiers can consist of letter, digit, underscore, and dollar sign. That's the same as C++, but for C++ we don't have dollar sign. So that's the first rule. And then the other rule is that the identifier needs to start with a non-digit. So if you create an identifier with, for example, one student, right? First you bring one, then a student, then this identifier is not acceptable in your program. But the reverse, for example, student 1 is completely acceptable. And then the name of the identifiers are case sensitive. What it means, for example, if you write down in your programming language capital AX and also use a lowercase x, you can use both of them and the compiler will can separate them from each other because the Java programming language identifiers in this programming language are case sensitive. So the compiler can completely recognize the difference between a capital X, X or a lowercase x. Then we have reserved words. So as we talked about that before, reserved words are those words that are predefined in our programming language. So they have a special meaning for the compiler. For example, int, right, or public, or class, or main. All of these words are some uh, reserved words. And the other rule is that the identifier that you define can be any length. So that's about some rules in identifiers. So when you follow these rules as the identifiers, the other thing that is good to know when you are creating your program is that it's good if you, for example, when you define the classes or interface names, right, you create the names, those names with an uppercase letter. So for example, if you are going to create a class and the name for that class be student, it's good if students, the S in student be uppercase. But for variables and methods, it's good if the name of them start with a lowercase letter, right? So that's the other point for naming the variables and methods. And for constants, right, when you are going to create a variable which is constant, which is fixed in your whole program, it's good if you use all capital uppercase letters for your constant, right? So it's the capital completely. So these are some rules about creating uh, identifiers, right, and specifying the names for your identifier. So we talked about variables, right? We mentioned that each variable can has a type. So in Java, like other programming language, we have some primitive data types. They are basic data types that are predefined for the language. So they can be char, boolean, integer types, or floating point types. As you see, char is 16 bits, right? Or char is actually used for storing single character. For example, letters, digits, special symbols, right? Boolean is the other data type that can be true or false, right? And then we have integers. Integers are suitable for storing integer values. They can be byte, short, int, and long. And as you see here, each of them can has a separate size. Then we have floating point types, right? For storage of decimal numbers, float or double. And as you see, float is 32 bits and double is 64 bits. So, so then we have declaring the variable. So inside the block, you need to declare the variable. So how you can declare a variable? First, you will write down the type name of that variable, then variable name. So if it's integer, so int num student as you see here, or double is the type name, right? And weight, which is that variable, or char letter, boolean flag, right? What if we have several variables with the same type? So for declaring such variables, we will use int, for example, the type name of those variables, and then we write down the name of the variables, right, sequentially and separate them by a colon and at the end semicolon. As you see here, int test1, test2, and final exam, semicolon or double average, uh, comma, right, GPA and semicolon. So that's how you can declare a variable in a block. So when you declare a variable, actually what you do is that you will say to compiler that this variable exists and the type of the variable is, for example, integer is float. So the compiler will recognize that variable by its name and will specify a space for that variable in memory based on its type. You saw in the previous slides, right, that each type um, can has a separate size. So the next step is initializing a variable, means giving a value to that variable and right, or loading a value into that variable for the first time. For example, um, here we have three variables: int num students, double weight, and char letter. So the first one is integer type, the second one is double type, and the third one is character type. So we have declared these variables, then we are going to initialize them. How? First, we write down the name of that variable, then equal sign, then that value. For example, non-students equal 10, or weight equal 160, or letter equal A, right? So as you see here, declaring the variable and initializing the variable have been done in two separate steps, but you can make your code more compressed and cleaner. How? By declaring and initializing the variables all at one step, right? So, as you see in this example below, int num student equals 10, or double weight equals 160, right? And so on. You see the other examples as well. So that's how you can initialize your variable. In Previous slides we talked about constant, right? We mentioned that a variable can be constant. So what it means by constant variable? A constant variable is a variable that has a fixed value. So if you define a variable to be constant and assign a value to that variable, then during the program, that value won't be changed and you cannot change that value, right? So how you can create a constant variable and what is the appropriate um, reserved word for constant. So if you remember in C++ or C, to declare a variable to be constant, we use const, right? But here in Java, the appropriate word is final. So for example, as you see in this example, we have final double pi then equals the value, right? So final, by using final, you are saying to compiler that you want your variable to be constant. So during your program, the value of this variable will not change at all. So we have operators, right? So for operators, as I told you before, we have unary operator, binary operator, and ternary operator, right? The unary operator has just one operand. For example, as you see in this example, we have x plus plus, right? Or for binary operator, we have two operands. For example, x equals y plus z. Then the other rule for operators is the cascading, right? When we, in one statement, we have several operators and operand. For example, in this example, we have x equals a plus b plus c minus d plus e, right? So as you see, we have several operators and several operands, right? All in single line of code. So this is cascading arithmetic operators. Arithmetic because the operators that you see here, right, they are all plus, right, plus and minus. So they are arithmetic operators. Then in the next example, we have x equals y equals z equals 3. So this one is cascading assignment operators. Assignment because we are going to assign the value 3 to all of the operands that we see here, x, y, and z. The other rule for operators is precedence. It means when we have in one single line of code several operators, how we can handle that, right? For example, in this example, we have x equals a plus b multiplied by c. So in this single line of code, we have 3 operands and 2 operators, right? So how can we, how actually compiler handle these several operators together? Which one would be processed first? Is it plus or multiply, right? So the answer here is first, compiler will calculate and find the result for b multiplied by c, right? And then we'll add the result of that to a, right? So as you see here, there is some priority in operators for compiler, and when we have, for example, the addition and multiplication, first the multiplication task will be processed and the result would be add to what operator that has been left. The other important operator that we have is assignment operator. So what this operator is for assigning a value to a variable, right? So we have the assignment operator. Then the left side and the right side of that operator can be uh, on the right side we have the value and on the left side we have the variable. So the variable is a place for storing the value. So as you see here, we have x equals 5, right? So here 5 is called, for example, here is called the R value and x is the L value. But in the example line 4, we have a plus 3 equals b. So that's not an acceptable line of code because in the left side we just have to have the variable, the location that is going to store the value. So it would be more acceptable if we had a equals b plus 3. And be careful that the operator for assignment is different from the operator for comparison, so don't mix these two. The other type of operators are arithmetic operators. So they are responsible for calculating, right, and doing some arithmetic operations. For example, when you are going to add two value or divide, right, one value from the other value or subtraction, right, all of these are arithmetic operators. So as you see here in this line of code, we have double x equals 19, y equals 5, z equals z, and z equals x divided by y, right? So the final result for z is 19 divided by 5, which is 3.8. So division is one arithmetic operator, right? Or for example, we have x equals 5, y equals 3.6, and z equals x plus y, right? So z here, the result of z would be 8.6, right? So we have shortcut assignment operator. So sometimes it happens that in one line of code you have on the right hand side and the left hand side the same uh, variable has been repeated, right? And actually what you as a programmer are going to do is that you want to add a value, right, to a variable and then store that value inside the same variable. You can use it like that. You can write down like that v equals v plus e or v equals v minus e. So the result of v, the value of v would be the value of v plus the value of e. So as you see here, v has been repeated on the right hand side and the left hand side. So you can reduce the task and omit the v that is in the right hand side, right, and bring the arithmetic operator on the left hand side of assignment operator. So instead of writing v equals v plus e, you can write down v plus equals e. The result is exactly the same as the previous one, right? Or v equals v minus e, you can write it v minus equals e, right? So you have omitted v in the right hand side and you have brought the arithmetic operator minus here in the left hand side of assignment operator. So as you see, you have made it very shorter, right? And your code would be very cleaner and shorter. So that's a better way, and it's preferred to write it like that. The other type of operator is increment-decrement operator. So let's see what they are and how they are different from the usual operator. So probably you may need to increase the value of one variable or decrease the value of one variable by 1 in your code. So the common way to do that is, for example, if that variable be x, you will write down x equals x plus 1 for increasing the value of x by 1. For decreasing the value of x by 1, you will write down x equals x minus 1, as you see here in this example. So the other way to write this type of operators is, instead of writing x equals x plus 1, you can write it plus plus x or x plus plus. Or instead of writing x equals x minus 1, you can write x minus minus or minus minus x. So they all do the same task. But here there is some very small difference between plus plus x and x minus plus plus, or minus minus x and x minus minus. So the first one, and plus plus x, is pre-increment, right? And x plus plus is called post-increment. Minus minus x is called pre-decrement, and x minus minus is called post-decrement, right? So here, when you are using, for example, a pre-increment like plus plus x, the value of x will change, right? Will be increased by 1 at that line of code. But when you use the post increment x plus plus, the value of x will increase after that line of code. For example, in the example below, we have x be 5 and count be 7. Then we have x multiplied by plus plus count. So the result here would be x multiplied by count plus 1. So we have 5, right, multiplied by 8. So the result would be 40 and the count would be 8. Or when we have int x equals 5 and count equals 7 and result be x multiplied by count plus plus, right? The result of this arithmetic operation is x multiplied by count. So 5 multiplied by 7, which is 35, right? And then after that, the value of count will be increased by 1. So if in the next lines of code you call count, you will see that the value of count has changed to 8. So in this example, you easily can see the difference between pre-increment and post-increment. So for variables, we had different types, right? We had integer, short, int, long, and we had float, right? float, and double. So each one had a different size. You can convert one variable, the type of one variable, to another type. And in programming language, it can happen in two ways. The first way is automatic type conversion. It happens by compiler, especially when two different variables with two different types has been assigned to each other. For example, you are going to say A equals B, and A and B each has different types. So compiler will convert the smaller numeric type into the larger one. For example, in these lines of code, you see we have I1 is integer and B1 is byte, right? So then we have I1 equals B1. I1 is integer, but B1 is byte, right? So as a result, what we will have is the value of I1 would be the same as the value of B1. And their types would be integer. The other conversion is explicit cast operation, right? So this type of conversion will be handled by the programmer. So you as a programmer will change the type of one variable. You most of the time use it whenever you want to assign a value of variable that has a different type, right, to a variable with another type. So to do this operation, you will change the type of the variable in the right hand side, right, first, and then you will do the assignment. For example, in this example, you see we have I2, right, with type integer, and then we have D1 with type double. So if we want to assign the value of D1 to the variable I2, since both has different types, what we need to do is change the type of D1 into integer because I2 is integer, right? And then do the assignment. So that's why we write I2 equals int D2, right? So that's cast operation.